Are we gone? Oh yeah, we are. Okay. I am Alan Geister, and this is my pseudocode for my matrix operation project. So this is the input correction function. This only ever gets called when a error condition has been fulfilled, and it basically asks the user to re-enter values for the row number and column number of matrices A and B for options um, for options addition, subtraction, and multiplication. This is my get determinant function. It basically calculates determinant using a basic formula for a 3 by 3 matrix. This is my matrix operation function. It basically checks, you'll enter in your row number and your column number for both your first matrix and your second matrix, and then it checks the operation, and based off the operation, it'll either um, add or subtract for this condition. For this condition, it'll be multiplication. Here you have this formula for the summation for basically element 1 times column 1, no, row 1, column 1, row 2, column, first element in row 1 times first element in column 1, second element in row 1, second element in column 1, so on and so forth, and then resets the sum when the column iteration is done. Then when the k iteration is done, it'll set the resultant matrix equal to the value of the sum, and then print the result. If the operation, this condition checks if it's transposed, and based off that, switches for the result, the column number becomes the row number, and the row number becomes the column number. And from here, it just sets the result uh, value based on, so this is the column number and row number to the uh, matrix A, or the matrix the user enters, and then prints it here. And then the last condition of this if statement calculates the determinant for the equation matrix. And then, well, but first it checks if the determinant is 0, since here this can be changed to like a threshold is less than or equal to, like, for example, 10 to the negative 4. That might be better for more robust systems where there might be some float error. Then it then I declare matrices X, Y, and Z, where basically in each one of these it just checks and then determines based off the column number which column to replace with the solution matrix, which is matrix B, which is an argument of this as you saw previously. Then after it gets the matrices of X, Y, and Z, it calculates the determinant for the X matrix, determinant for the Y matrix, a determinant for the Z matrix, then divides the determinants by the determinant of the equation matrix, and then prints the answers. And that's the end of this function. This is the get matrices function. It basically, sorry, 1 second. It basically, what is the row number? Asks, it's like, it's this entire function is just a bunch of conditionals to format how to ask the user to enter either a row number or an element of a matrix. This entire section is just different based off the actual operation that's being performed that the user wants to perform. It changes the phrasing of the question a little bit. For example, here, if it's not transposed, it'll ask it for matrix A or B. If it is transposed, it'll just ask for one matrix. It'll ask a question as if it's just the only matrix that exists. And then throughout this entire function, this is also the function where my failure conditions are located, where it basically checks based off the operation whether, for example, addition subtraction, whether it's a square matrix, for multiplication, whether row the column number of the first matrix and the row number of the second matrix are equal. And obviously it checks all operations if the row number and column numbers entered are greater than 0, because you can't have, because that would be an invalid dimension. Then here, after the failure um, the failure conditions are checked. I define the matrix A and B here. Based off the operation, I basically change the phrasing of the question on asking the user to type in a row and column element. Here, I just print the matrix. Um, in this section, I just print the matrix based off what the user entered. And then I also, if the operation is addition and subtraction before going on to the result, I ask if it is addition subtraction, if the user wants to add or subtract. If they And based off this input, it determines the operation used for the resultant matrix for addition or subtraction. And then the operation becomes the input because this is the input. But for here and every other condition, it's just the operation variable or argument, I mean. And this accounts for transpose and transpose multiplication and the system of equations. And then that's the end of this function. This is my main, where it will prompt the user to enter a character for a different matrix operation. This one checks if the user input is valid, and then based off user input, it calls the get matrices for all of the different operations. Um, because I call a function within a function, I call the operation matrix operation function in the get matrices function, as you saw previously. And then based off that, after the operation is done, it returns 0 and then exits out of main. This begins the AI pseudocode section. This is a function that just gets what that you gets called to just get whatever matrix user entered. This displays whatever matrix, so if you want to display the resulting matrix, this does it, or the user entered matrix, this does it. The AI decided to separate the add and subtract functions into add and subtract operations into different functions. I think this is unnecessary, as it's almost identical code except for the signs. This is the multiplication function, very similar to my code, pretty much almost identical in the format. This is the transpose function. Again, it's just defining it based off switch column and rows. Very similar to mine, just different variable names. Although they all use different arguments because they decided to separate the operation into just different functions entirely. But this is, anyway. This is the determinant function. Primary difference is he separates the terms instead of just adding it into one big variable. The AI decided to separate each like individual term into its own equation. Same thing effectively, but it might be easier to look at. Solving system of equations, it defines local variables, and then similar technique to mine. I mentioned this earlier, using a value close to 0 instead of is 0 due to float issues. Here, instead of what I do where I check the column and then enter in the solution matrix based off the column, how the AI does it, they typically make the X or Y or Z matrix just the entirety of matrix A, and then use a loop to replace the necessary column with the solution vector. And then after that, it just defines the X and Y determinants. And then here, oh wait, I need to do that. And then here, after everything, after all the matrices have been determined, and all the determinants are defined for x, y, and z, it gets the x, y, and z values and then returns it as a solution vector or a solution array. Then this is also another area. So instead of having the get matrices in one function like I have it, I Gemini separated everything into handles. So the and it's basically the same as my big code that checks the conditions for printing, except there's just a lot of repeated code across all these functions. They're all slightly different, which is why, but like the reason I didn't do it like this is simply because it's just too much, and I think it's unnecessary to separate the handling of each of them, each user input to be separate functions. It's just not worth it. And this is a consequence of using an array instead of just simply variables and then printing the variables. Then this is how the AI decided to structure their main. It's pretty much the same as mine, except that they decided to use an exit value, an exit prompt, and then here it just calls the handles. And instead of using arguments to determine um, which operation is being done and then doing an operation based off that in one function, it's all separate. And then here's the also another difference. The AI uses switch case, I use else if. Doesn't really matter as it accomplished the same goal. But anyways, besides that, now the primary pseudocode I'll be using is mine because I don't really like how the AI structures their pseudocode. But other than that, you've heard my thoughts, and this is my matrix operation project. Thank you for watching.